more than 50 patent applications, and he has led the conversion of a line of top-mount refrigerators from R12 to R134A. So with that, I'd like to go over my slides, which is an overview of JUMP, and then I'll turn it over to Brian and Brent to go through the technical backgrounds of our campaign today. So why are we doing crowdsourcing? Basically, we want to open up a platform for innovative ideas in the area of energy efficiency and building technologies. And so with our collaboration with GE, we're doing just that. And the White House recently put out a blog about what crowdsourcing is and said, while only a fraction of Americans are formally trained as professional scientists and engineers, everyone can contribute to science through activities such as crowdsourcing. And Dr. David Danielson, the U.S. DOE Assistant Secretary for Energy and Efficiency and Renewable Energy, also promoted crowdsourcing by saying it's great because the smartest people don't all work for you. So what a great way to get thousands of ideas for innovation through a website. Other organizations are leaders in crowdsourcing, such as General Electric and Local Motors. So last year we started crowdsourcing at Oak Ridge National Laboratory, and we did this through 3 fairly simple campaigns. We weren't looking at a specific technical challenge. We were looking just generally in the areas of envelope technologies, equipment technologies, and sensors and controls, and just looking for innovative ideas in those general spaces. And we were very pleased that we had over 5,000 unique users to our website, and we're able to post over 70 valid ideas. And we judged those ideas. The website was open for anyone to vote and provide comments on those ideas, but we also had an independent panel of judges who evaluated those ideas for technical feasibility and potential energy savings. And each of those winners, we had 1 winner per campaign, were provided the opportunity to come to our event that we hosted at Oak Ridge National Lab in September called ERE Industry Day to present their concepts and network with other potential partners and think about taking their idea to the next level. We 3D printed one of the ideas. One of the participants submitted their idea to the Small Business Voucher Program, which we'll provide a link to from our website. And we're also talking about a potential cooperative research and development agreement with another winner. So this is a great way for people to share their ideas and really try to move the needle in energy efficiency. So what we're doing in this year is we're having a public-private partnership. And what we're doing is trying to focus on specific technical challenges that our industry partners would like to solve. And what provided the website here, General Electric is providing a $3,000 cash award for a winner for their technical challenge, which they're going to talk more about. And there's also opportunity for ORNL to provide in-kind technical support for the winning ideas across the 3 campaigns that we have ongoing right now, including GE's, and more that we plan to post this year. I mentioned that we're providing this linkage to the Small Business Voucher Pilot, which is at fbv.org. The first round just closed, but the next round opens in February, and that provides, if approved, up to $300,000 of technical support. Also, it provides an opportunity for the innovators to discuss potential future collaborations with ORNL and others. Moving to the next slide, how does it work? Well, people post their ideas to the campaign, and then Oak Ridge National Lab will review those ideas for technical, economics, market readiness, consumer interest or need. And then if they're applicable, we're going to post them to that JUMP website, and there the whole world can comment and vote on those ideas. And we're going to allow that for 8 to 10 weeks to be online. And next we're going to convene that panel of judges where we're going to decide which ones are the very best, have the most opportunity for our industry partner. And then, as I mentioned before, those best ideas have a variety of opportunities for taking it to the next level. And we're very excited to be offering this opportunity to innovators across the world. So how does your idea work? What about the intellectual property? That's a question we get quite often. So the innovator should protect their intellectual property or their idea before they would post it, because of course once it's on a website, it's publicly available. When they move to the next level, if they're a winner, then they're going to have opportunity to have a future intellectual property, and that may be joint IP. For instance, when O&L might contribute to the idea through the technical support or the small business voucher process, or when the industry partner adds to the idea through co-design, co-creation, co-development. So in summary, this last slide that I have talks about our current campaigns. We have 3 active campaigns, and I encourage all of you to go out and take a look at those technical challenges, and know that there are cash prizes for those winning ideas. There's also in-kind technical support that's available for the winning ideas. There's a linkage to the small business voucher program, and there's potential for future collaboration with O&L and other industry partners. So with that, I will turn it over to Brent Junge from GE to talk about the technical.
Okay, welcome. So this challenge is about how to design a defrost heater for an R600A system. So I guess next slide. The big thing with R600A is it's slightly flammable, but it's a very popular refrigerant. It's used pretty much throughout the world, except in the U.S. It's taken over most domestic refrigerators in Europe, Asia, South America. The big problem with implementing it in the U.S. is, that it's flammable. In order to implement it, you have to comply with a lot of different codes and regulations, and of course you have to make sure that the product is entirely safe. One of the big requirements is around the defrost heater. So the defrost heater cannot get the surface temperature on the defrost heater has to be limited if you're going to use it with a flammable refrigerant. So let me talk a little bit about what a defrost heater does before we get into the more detailed requirements. So in big picture kind of viewpoint, when you refrigerate an appliance or refrigerate a space, the air cools down, the moisture in the air has to come out. It tends to collect on the coldest spot, which is the evaporator, which is normally a good thing because you don't want the frost or the water all over your dishes or packages. But occasionally we have to defrost the evaporator because as it collects too much frost, it impedes airflow, and then it insulates the heat exchanger so that it becomes less efficient. So the defrost heater works by you turn the product off, you add some heat in some fashion, which then melts the frost. The water then goes through the drain pan, goes into the drain pan, and then usually flows out from the drain pan through a drain tube. And this is just some pictures of a top mount refrigerator. In the back of the freezer is typically where the evaporator and the defrost heater are. So that's figure 1. Figure 2 just shows the evaporator without the evaporator cover in place. And then 3 is a picture of a radiant heater, which is what's used in a lot of GE product. Next slide. So typically you locate the defrost heater under the evaporator so that, and it works pretty well there because most of the frost forms at the bottom of the evaporator. The heat from the defrost heater rises, so it eventually warms up the top of the evaporator also. And it warms the drain pan, which is where a lot of times when some of the frost will fall off the evaporator, it'll still be a little bit solid when it hits the drain pan. So you need something that heats the drain pan to make sure that it all becomes water and leaves without freezing. The picture on the left is a plate and tube type evaporator, which is commonly used in a lot of refrigerators. And the one on the right is what we call a spine fin evaporator, which happens to be used in a lot of our refrigerators. Next slide. So there's a lot of defrost heaters that people use. Starting in the upper left corner, the ceramic insulated, those are what's commonly referred to as a cal rod heater. They have a nichrome wire, they have a magnesium ceramic type insulation, and then they have a metal sheath. Some of them have aluminum sheaths, some of them have steel sheaths. The aluminum sheath you have to keep, what won't get to as high a watt density, or you have to keep the surface temperature lower with aluminum, but it's good from a corrosion standpoint typically, and is a little less expensive. On the bottom left and the bottom right is a picture of the radiant heater used in GE type product. It's contained in a quartz tube, and it's basically just a coil of heater wire contained in a quartz tube. So when you turn it on, it'll glow red and actually radiates heat through the evaporator compartment, melting the defrost. I took the picture on the left is a picture of the bottom of the evaporator showing where the defrost heater is, because if you look at it from the front, seeing as it's a glass tube and the wire is pretty thin, you can't even really see it. Then in the upper right is a silicone wire defrost heater. What that is it's a heater wire in a silicone rubber sheath that's then put into an aluminum tube, and those heaters tend to be very long. They're used a lot in Europe, and they're used a lot with R600A because they run at a much lower temperature. But in order to get that lower temperature, you have many, many feet of defrost heater, so it ends up being kind of expensive. Next slide. So with respect to R600A, which we'd like to use because of the lower global warming potential, and because it's quieter and because it's become the standard refrigerant throughout the world. With respect to defrost heaters, the specification requires that we have no surface temperature that's above 360 degrees, and that could possibly be exposed to a refrigerant leak. So you can have surface temperatures above 360 if they're in an area that cannot possibly see a leaked refrigerant. Otherwise, anything that's directly near the evaporator would need to be below 360. Next slide. So that's kind of the gist of the challenge. R600A, like I said, is a very good refrigerant. Low global warming potential, typically lower sound level. Typically products that use it use a little bit less energy. The big not the only hurdle by any means to getting more widespread adoption in the U.S., but one of the hurdles is the defrost system. So we're interested in ideas to defrost an R600A system while conforming to the UL 250 specification. So I think that's pretty much what I got on this.
Okay, great, thank you. All right, Brian,
all right. Next slide, please. So what I'd like to do is just briefly give you some motivation why Oak Ridge National Lab is interested in working with industry to develop the next generation of domestic refrigerators. So next slide, please. Oak Ridge National Lab works with the DOE Building Technologies Office. And the mission of the Building Technologies Office is to promote efficiency, affordability, and environmentally friendliness. And in doing so, we conduct R&D with industry cooperation and try to advance innovative technologies and bring them to market. And so for the past 30 years or so, ORNL has worked with major manufacturers in the appliance and HVAC and R fields to develop the next generation products. And so we'd like to continue that effort and bring energy efficient, environmentally friendly refrigerators to the market. Next slide. So just to kind of give you an example of this collaborative effort between industry and DOE, how that's benefited everyone over time. So here we see the energy consumption of refrigerators for the last 30 years or so. The orange line there shows the energy consumption of refrigerators. And so through this collaboration with industry and DOE, we've been able to reduce the energy consumption by 75% from 30 years ago. And at the same time, if you look, the green line shows the volumetric capacity of the refrigerators has increased. And then the blue line shows the cost of the refrigerators. And so cost has come down. So we're making more energy efficient refrigerators at a lower cost and also with larger storage volumes. Okay, next slide. So like I say, Oak Ridge wants to work with industry to continue to enhance refrigerators and freezer performance. And one way to do that would be to use isobutane or R600A as a refrigerant. And why use isobutane? Compared to the current refrigerant, 134A, it gives us an energy efficiency increase up to 4%. And at the same time, isobutane has a significantly reduced global warming potential compared to the commonly used 134A. So the GWP of 134A is about 1,400 versus 3 for R600A. So we get an energy benefit and an environmental benefit by going to isobutane. But there is a challenge. Isobutane is a flammable refrigerant. However, for refrigerators, domestic refrigerators, the quantity of isobutane in the system is small, on the order of ounces. So it's probably something that we could overcome. Okay, next slide. So if we could convert all the refrigerators in the U.S. to use R600A, we'd increase energy efficiency and lower our GWP. It's estimated that the source energy consumption on an annual basis could be reduced by 38 tera BTUs per year. And in addition to that, we could reduce the annual consumer energy costs by about $340 million per year. And then I mentioned about the lower global warming potential. By going to 600A as a refrigerant, we could reduce our greenhouse gas emissions by over 2.7 million tons per year. So some motivation there to move to this 600A as a refrigerant in domestic refrigerators. And so with that, I'll hand it back over to Melissa.
Okay, I think that concludes our webinar information, and there's a final slide here that shows what the deadline is, January 15th, to submit ideas, and our contact information for the 3 presenters today is listed. And with that, I'll turn it back to Tyler to see if we have any questions.
Yeah, thank you. We do have a few about the nature of the campaign generally. First is, who is eligible to participate in this challenge?
That's a great question. So if you were to go under the terms and conditions on the JUMP website, which is web.ornl.gov/JUMP, you'll see that the campaigns are open to legal residents of the 50 United States or District of Columbia who are at least 18 years old at the time of entry.
Excellent. And then we also have a question about just generally how the voting works. You might be able to touch again on kind of the importance, maybe just how that factors into the entire campaign.
Sure, absolutely. So once ORNL approves an idea as valid to the campaign and it goes online, then it's open for comments and people to click, that they like it or they don't like the idea. And that tallies up. So one idea might have 15 votes for it and another may have 2. However, when we do get to the end of the campaign, we are going to look at all the ideas for their merits. So just because an idea doesn't have a lot of votes doesn't mean that we're not going to consider it.
Excellent. And again, I'd just like to encourage anyone on the line, if you do want to submit a question, either on the campaign or maybe even more technical nature, just use the question answer box on your webinar panel, and we'll certainly do our best to answer it. I've got another one. Are ideas limited entirely to new products, or are retrofit solutions also considered?
That might be a good question for Brent.
Typically, we couldn't retrofit our 600A into a refrigerator because beyond the defrost heater, you would need to change the compressor, which would be very expensive. Then you would need to change all the electrical components have to be rated not to put out any sparks. So normally there just isn't a practical way to retrofit a refrigerant from a non-flammable one to a flammable one. So typically it has to be a new product. Now if people had ideas, we would probably test them on, you can test them for efficiency on existing products, but you couldn't actually convert an existing product or in an authorized manner.
Okay, great. And that was a great question.
Do you have any insights or guidance as far as how intellectual property of the ideas will be handled as they come in?
So I think, as I mentioned in the slides, people who are going to submit their idea that is their idea and they own it, and if they want to protect that, they should do that before they submit their idea.
Melissa, do you mind going back to the IP?
Sure.
I think it just mentions clearly on that slide that idea submitters do own the IP of the idea completely, slowly or jointly, until unless there's a situation where ORNL or the industry partners add to the idea. So I just wanted to bring that up again.
Yes, absolutely. And these slides will be available on our website after the webinar for reference. And if there's more follow-up questions, anyone's welcome to email me as well.
Are there any more questions?
I think we have a few ideas already on the website for this campaign, and we look forward to many more before January 15th.
So give us a few more minutes in case there are any other questions that are lining up. But again, we encourage folks to send in their questions through the chat box or raise your hand, and we'll be happy to unmute your line.
And I would like to mention we're having 2 more webinars tomorrow on the 2 other campaigns that we currently have posted. We'll be having a webinar at 2 p.m. Eastern Time tomorrow with UTRC on a low-cost BTU sensor for use in building HVAC control systems. And then at 3 p.m. Eastern Time with A.O. Smith, and their campaign topic is improving thermal energy storage for water heaters.
So there may be folks on the line that are interested in joining these other webinars. They have colleagues or folks on the network that would be interested to join the webinar as well.
Sure. There's still time to register.
Awesome. And will the webinar be recorded again?
Yes, all 3 are being recorded, and they'll be posted on our website for reference.
Awesome.
All right, everyone. Just want to thank you for joining us. Again, if you have any questions, certainly get in touch. You know, source Melissa mentioned resources in the deck. Also visiting the JUMP website. You know, visiting our FAQ might answer any questions you may have, and there's an email address in that section as well. We're happy to take any questions you may have. Again, as well, you know, if there's any other webinars, the other 2 webinars, please feel free to join us tomorrow. That information is also listed on the JUMP homepage. And aside from that, we certainly look forward to hearing from you with all of your ideas and your thoughts. Thank you very much. Have a wonderful day.
All righty.
Thank you.
Thanks a lot.
Thanks a lot.
Thank you.